All right, let's talk about objects floating in a fluid. Specifically, what we want to know about today is how much of the object is above water versus below water. So, what is our basic equation that we have to determine the buoyant force? And what do we do with that in terms of Newton's second law? Well, the buoyant force equation, if you remember, is that the density of the fluid is equal to the volume submerged, or the volume displaced, times gravity. So the volume of the fluid displaced. Yeah. So then what we do with it is we take this guy and we draw a free body diagram. We say we've got the weight going down, and we have a buoyant force going up. And if it's floating, those must be equal. So I would say Newton's second law tells me that F equals ma. And so then if we do up minus down, and we know that A is 0, because we want it to be floating, I would say buoyant force minus weight equals 0. So then that tells me that buoyant force equals the weight, as I'm sure you guys already know. So let's come over here to the right side, and we'll do it over here. So the buoyant force equation is rho VSG, which I just wrote to the left a second ago, but that's going to equal mg now because I want it to equal the weight, right? So those g's cancel, right? And so now, how does this help me figure out how much is above or below? Well, I can rewrite the mass to be, let's make this density of fluid specifically. I can rewrite the mass to be density of object times the volume of the object, or the volume total, maybe is a better way of saying it. So let's put that in. So now I've got rho of the fluid, volume submerged is equal to density of the object times the total volume. So now if I want to know what percent of the object is below water, well then I'm just going to solve for the ratio. Vs over Vt will get me the fraction of it below water. Fraction submerged. If I want percent, just multiply by 100. Okay. So, but what that then is, I just divide by both sides by Vt and then by rho f. So Vs over Vt is equal to rho density of my object over density of my fluid. And that's the percent. Well, then if I want percent, I would say multiply by 100, right? So that will tell me what fraction of my object is underwater. Now if I want to know what fraction of my object is above the water, well then that's simply just going to be fraction above. Oop, missed my C. Will equal V above over V total, right? But to get that, I know that, let's come back over here and get myself some, let's just slide up. So I know that volume, this is probably more work than you guys really need. I mean, the short version is I'm going to do 1 minus this term will get me the fraction above, or 1 minus this will get me the fraction above. But now I'm going to prove it, and I think it's going to take more work than you guys are going to see. But prediction, the answer is going to be 1 minus rho object over rho fluid. Because you can just do 1 minus both sides, because 1 minus this will equal 1 minus that, right? Is fraction above. Okay, so proving this. So I know that VT is equal to V submerged plus V above, right? So then if I take 1 minus this guy, I do 1 minus Vs over Vt, I know I can rewrite that as Vs plus Va over Vt minus Vs over Vt. And I can write this like this because we said those are the same thing, right? So this is just equal to 1. But now when I do the subtraction, I lose this term, right? So then this is going to get me volume above over volume total. And now finally, the last step, putting equal to something. Since I did 1 minus this side, I also had to do 1 minus that side. So that tells me that VA over VT is equal to 1 minus rho naught over rho fluid. All right, and that is going to be my fraction above the water. All right, I'm going to call that one quits. Keep this one relatively short. Hope you guys enjoyed the video, and I'll see you in the next one.